video is going to help you determine an ionic formula from the name. Okay, so I'm already assuming that you did that first critical step. When you looked at your name, you decided that the first word represented either a metal or ammonium. So therefore, you want to determine an ionic formula. Okay, so let's get started. Separate the positive ion name from the negative ion name. Okay, it's usually just the two words. Just separate them. Easy enough. Then, for each ion, write the ion formula and charge. Okay, so aluminum is Al, and its charge is 3+. Oxide, the IDE ending, you can just ignore that. Oxygen is O, and its charge is 2-. Next, choose subscripts to balance the charges. Okay, the way that we balance charges is by finding the least common multiple of the two charges. Okay, well, the least common multiple of 3+ and 2- is going to be 6. Okay, so for this one, our least common multiple is 6. Then I'm going to determine the subscript from the charge. So for aluminum, since the charge is 3, and we don't have to worry about the plus and minus, 3 times 2 is going to be the 6. So aluminum is going to get a subscript of 2. Oxygen, on the other hand, has a charge of 2-. Okay, again, we don't have to worry about the minus. So its subscript would be 3. Okay, as you notice, especially with the note here, it says charges often crisscross with the subscript. Well, that happened in this instance. If you'll notice that the 2 here showed up there, and the 3 here showed up there. Okay. All right, let's try the next one. Okay, separate the positive ion name from the negative ion name. Include any Roman numeral with the first name. Okay, so if you get Roman numerals, call yourself lucky. If you're given the Roman numeral, you don't have to determine what the charge is, because the Roman numeral is the charge. So if I, for each ion, write the ion formula and charge. So iron is Fe, and since the Roman numeral is 3, the charge is 3+. That's an easy one to look for. Don't look on your periodic table if you have Roman numerals. The chloride is a Cl, and its charge is 1-. That comes from chlorine. Okay, so now we need to balance the charges. Okay, so balance the charges by finding the least common multiple of the two charges. Okay, the least common multiple of 3 and 1 is going to be 3. So for this one, it's 3. The charge for iron is a 3+. We don't have to worry about that. So my subscript on iron is going to be a 1. Because it's a 1, I'm not going to put anything. I'm not going to put anything here. Okay, so I'll just erase that. All right. Now for the chloride, since the chloride has a charge of 1-. Okay, again, we don't have to worry about the minus. And we want it to be a 3. The subscript for that is going to be 3. Again, if you'll look at this, this works very often. The 3 up here crisscross down here, the 1 crisscross down there. Let's try another one. All right, so sodium carbonate. Let's go ahead and split the 2. Sodium is Na, and its charge is 1+. Carbonate is CO3 2-. Okay. Now, something I'm going to tell you, a lot of you may want to put parentheses around your polyatomic ions. Because if you need more than one of those, you're going to want to make sure that you have parentheses. Okay, so let's do this one. The least common multiple for a 2 and a 3 would be a 2. So my sodium, with a charge of 1, is going to need a subscript of 2. And my carbonate, with a charge of 2 minus, is going to need a subscript of 1 in order to get my 2. So literally, for this one, I don't need the parentheses on this one. Okay, so I can erase the parentheses because I only have 1 carbonate. So the formula is Na2CO3. Okay, if you'll notice again on this one, notice you're going to have to remember that CO3, because there is a polyatomic ion, because there's no parentheses means that there's 1. So this kind of represents just one of those. The 2 right here, once again, we kind of did a crisscross thing. Let's see if it works on this last one. Okay, so step number 1, what we want to do is split. Luckily, we've got a Roman numeral, so we know that lead, Pb, has a charge of 4+. Okay? Sulfate has a charge, sulfate is SO4, and it has a charge of 2-. Okay, so I want to go ahead and put my parentheses around my polyatomic ion. Okay, if I notice on this one, my least common multiple is with a 2 and a 4 is going to be 4. So for lead, its charge is 4+. I'm going to need a subscript of 1 on that. So I don't need to put anything right here. Okay? With the sulfate, the charge on my sulfate is 2-. So the subscript here needs to be a 2 in order to get my least common multiple of 4. So that's where my parentheses come in, and then I place the 2 on the outside. If you'll notice, the crisscrossy thing didn't work this time. The reason being is that 2 is a multiple of 4, or 2 can be multiplied by 2 to get 4. This is some of the trickiest stuff that we do for naming. Hopefully you're having a great time with this. Remember, this is the way that you determine the ionic formula for a name, and my name is Karen Hill, and I sure hope I've helped.